Alright, this is topic 73. This is disc or washer, and you're going to see why it says such things. So let's do example 1. Example 1, this is related to what we did on 72. So all they want us to do is to find the region that's being bounded by y is equal to 0, which is this, the x-axis. Y is equal to 4, which I do not have here. So y is equal to 4, let's make that up here at the very top. Okay. And this function right here. So the area that's being bounded by this one, and that one is this area inside of here. Alright, so that's the area that's being bounded. Alright, and now they want us to rotate around the x-axis. Now, if you watch what I did yesterday, or whenever it is that you watch this, this is actually not very hard to do. We can, if you rotate this area right here, it would basically look like, I don't know, let's see if I do this correctly. It will look something like this, maybe. Right? And you don't have to do this, I'm just trying to show you what this would look like. Right, it would basically look like that, almost like a sphere, except without, you would be missing the top of this, like somebody chopped up that sphere at that point, and on the back the same. So if you rotate it like that, remember that we want to know the volume of one disk, if you remember that correctly. Alright, and the thickness of that disk would be what we call delta x, and I hope you can see that. I wrote it really small. So delta x is the thickness of the disk, right, or the cylinder. And again, we talked about how yesterday, if you want to figure out the volume of this, you would just need several disks, alright, that would be sitting side by side. And the thinner the disk, the better, the more accurate the volume is going to become. So if you have any questions about how to do this, go back and watch topic 72, which I did several of these examples. Right? So we found out that the formula was pi r squared, which is the area of the base, times the height, and the height would be the dx, or the thickness, and that delta x becomes dx once you integrate. So we're going to go between -2 and 2. And the radius, if you look at it, the radius is between here and the top of this line. Now the top of this line is indicated by this function right here. You can find the heights and different points using this right here. So the radius would be this. Square dx. Alright, so again, we're this inside right here. That's the radius. Alright, I'm going to call this capital R. That's the radius. The inside of that, so remember that the formula that we used before was pi r squared. I'm going to write this r like that, times the height. And that's basically what we have here. Right? So again, if you have any questions, go back and quickly look at what we did on 72. Alright, so if we put this in our calculator and we're integrate with our calculator, we get that the volume is equal to 144.094. Okay, and this would be units cubed. So that would be the volume. Alright, on the next one, it would be the same thing. Notice that we almost have the same shape. We have a region that's being bounded by y is equal to 2, which is this line right here, x is equal to 2, which is that vertical line, and x is equal to -2. Now they want us, this is the area that's being bounded. Okay, so if we want to rotate this, if we rotate it like that, we would have some some cylinder that would look like this. I guess if I want to get really proper about it, that's sort of what it would look like. And again, don't feel obligated to write this three-dimensionally. I'm just doing this for your benefit. Alright, so this right here, if you remember, we're going to find the volume of one disk. Alright, this would be delta x again. And the radius of this, basically from here to the top, would just be 2. Okay, so on this one the radius is a whole lot easier to see. The volume to find the volume using the disk method, we have this formula that we figure out on topic 72, where the radius is 2 squared dx. Okay. And on that one, if we put that in a calculator, or you can do that by hand, that wouldn't be too bad. We get that the volume is equal to 50.265 units cubed. Now, again, we haven't done anything different than what we did from 72, except for I'm just doing it faster, all right, just because I feel like I've already talked about it. Now, in example 3, what we're going to do here is the region bounded by y is equal to 2, which is this right here, y is equal to 4, which is that line up here, and this function. So the area that's being bounded is this. Now on this one, I'm not going to draw it three-dimensionally just because it gets kind of messy. Alright, but remember that this is what I have here, and they want me to rotate this around the x-axis. So picture this little piece right here. If it was rotated around the x-axis, you would have a hole right in the middle. Alright? So again, you would have basically what amounts to the shape of a donut, sort of. Right? You would have the radius on the outside and a smaller radius on the inside. So you would have what we call a washer. Alright, so to figure out the volume, and notice that this volume would be the volume of the disk minus the volume of the hole. And a hole, it's in this case is going to be what we did on example 2. Alright, so the volume of the disk, the total volume is equal to pi, the integral of the radius square dx minus pi r squared dx. Alright, where r is the radius of the big disk. So this one right here, let me write it in this color, see if you can see it better. This right here, this would be capital R. All right, that's the radius of this right here, the top line, if you will. And little r would just be that radius right there. All right, so it's basically the radius of the disk minus the radius of the hole. Okay, or the integration of those. So if we kind of look at that now, if we simplify this further, we have the volume is equal to pi integral of the radius squared minus the small radius dx. Alright, so again, in conclusion, we have that the volume of a washer is equal to pi times the integration of the radius of the big object, the big disk, if you will, minus the radius of the hole. Okay, so on this one right here, this one's a combination, by the way, in example 1 and example 2. So the radius of the first disk minus the radius of the second disk. That's what we're doing, all right, between example 1 and example 2. So on this one right here, the volume. And normally we put a VW here as in the volume of the washer. It's equal to pi. Now the radius, this radius right here, right, you're going to find that by using this function right here. From here to the top of any of this line right here, any of this line would be 4 minus x squared over 2 squared. Right, and you can argue that you can say 4 minus x squared over 2 minus 0. Alright, so that top minus bottom thing kind of applies to this also. And then we're going to subtract the radius of the hole. The radius of the hole would be from here to this line, which would be 2. And we're going to square that dx. And if we integrate this, we get that the volume of this washer is 93.829. Alright, Okay, so let's go to our next example, see if hopefully this makes a little more sense. Alright, so if we go to the back, we have example 4 right here. We have two functions. We have y equals x and y is equal to x squared. And this would be the area that's being looked at. In this case, I want to rotate this around the x-axis. So I usually put this delta x here just to remind me that I'm going to integrate with respect to x. So if you're wondering, when do I use the washer method? The answer is, if you spin this around, you're going to have a hole in the middle. And if you have a hole in the middle, then you're going to use the washer method. Okay? So on this one right here, we have the volume of the washer is going to be equal to pi. Oh wait, and I just realized I didn't put the I did not put the values here, so this is still from hold on just a second here. Yeah, this would be from -2 to 2. My bad. So make sure you do that. And that would be that point right here and this point over here. Okay, so let's go back to this. I'm sorry. So on this one, we have to figure out what this point is and what this point is. And in this case, those points are going to be 0 and 1. Alright, so we have to have our boundaries for this integration. So now we're going to go ahead and we're going to find the radius of the disk, the bigger one. Alright, so I want to find the radius basically. I'm going to put a line here. I don't know if this is very helpful or not. This would be r. Right, the radius from the x-axis to here is just going to be x. And if you remember, the formula is the radius squared. So this is going to be x squared. And then we're going to subtract the radius of the hole. Now the radius of the hole, and this is where it's starting to get a little messy here. Let me put this delta x up here instead. That right there would be this little r right here, that distance right there. I don't know if you can see that, is that little distance right here, which is, if you look at this graph, this is y equals x squared, so this would be x squared. And now we square the radius, so we have y squared squared dx. And then we plug that in our calculator, and if you plug this in the calculator, you get the volume of the washer is equal to 0.419. And again, if this gets a little too complicated for you, make sure and ask me. Alright, again, I don't really know how well you're going to understand this off of video, so make sure and ask me when you see me. Alright, now on this one, we're going to rotate, it's the same graph, but we're going to rotate around the y-axis. Alright, so we're still looking at this little area, but instead of rotating like that, we're going to rotate around the y-axis. Alright, so we're going to rotate like that. And notice that when we do, we're going to have a washer. We're going to have a hole in the middle. Alright, so I'm going to put this as delta y over here. This is delta y. Alright, so we're going to try to integrate everything with respect to y now. So notice that right here I wrote x is equal to the square root of the square root of y. And I got that from here just by solving for x. So I'm going to say that this line right here, this right here is x is equal to the square root of y. Okay, same idea. Now we're going to integrate the volume of the washer is going to be equal to pi between 0 and 1. Now notice that 0 and 1 just happens to be the same point. We're looking at the y coordinates of that point and the y coordinate of that point. And it just happens to be 0 and 1, just like the previous example. Alright? So now we're going to have the radius of the disk, the larger disk. Okay, so on this one right here, this is a little bit backwards. The radius of the big disk would be that right there. Notice that this line goes all the way into this. Okay? And the volume of the little one, or the volume of the hole, would be that right there, if you can see that. Okay, so if you can see that, we have pi integral between 0 and 1 of the square root of y square minus y square dy. And remember that I'm squaring these because of the formula. Alright, the formula says you're supposed to have pi integral of r squared minus little r square dx, or dy in this case. Alright, if you put this in your calculator, so again, you can put this in your calculator, you just have to replace the y's with x's, and that'll work out the same. So we have the volume of the washer is going to be equal to 0.524. Okay, so that's as easy as that. Please don't crack your skull trying to do this without a calculator. What we want to accomplish here is for you to figure out how this looks in your head without having to, rely on technology to draw a picture for you. All right, so this one I think is the most difficult one. So let's let me make sure you understand. So on this one right here, we're actually going to spin this around this right here. All right, so they want to spin this. So notice that this is still the area that we're looking at. This is still going to be dx, or sorry, delta x. If I spin this, right, so here's y is equal to 2. If I spin this, it's definitely going to make a washer. And I wish I could draw a better picture of this, but I can't. This would be pretty difficult. So that will definitely look like a washer, all right, where this is the outside, if you will, the outside of the donut. Okay? So if you understand that, you notice that the radius, in this case, the radius is going to be from this line to this line would be our radius, our capital R radius, and from this line to this line you have little r, or lowercase radius. All right. Now to find the radius, right, to find this capital R radius, what we need to do is we need to have, and I'm going to tell you the logic of it, then you can do with it what you want, but it's going to work out the same way for almost every problem, right? So we have that the radius is going to be from here to here would be 2, all right, but that's not the radius that I want. I don't want the radius from here to here. I just want that little piece. So if I have that 2 right there and I subtract this function right here, this curve, I would have that radius that I need. Okay, so on this one it always works out like this. You have the top minus the bottom curve. And if you do that, so if you don't know what I would just said, if you just do this, it'll work. Alright, so we have that the radius is equal to 2. See, we have 2 minus x squared. Notice that 2 is this line, x squared is this line, or this curve, I'm sorry. And for the little radius is the same thing. Again, same idea. If I want this little piece right here, I want that. So in order to do that, I need to have from here to here, and then subtract this little piece right here, and then I would get that. Alright, so same thing. We have the top minus the bottom. And that's honestly, a lot of the time, that's the hardest part to do, is to find the radius. We got 2 minus x. Because the formula is pretty easy. The volume of the washer is equal to pi between 0 and 1 of capital R radius. In this case, that radius is going to be 2 minus x squared minus 2 minus x. Oh wait, I just realized that's supposed to be 2 minus x squared, and this one's 2 minus x squared. Right, so again, notice that I'm getting those numbers from here. Dx, and if you put that on your calculator, you'll get the volume of the washer is equal to 1.676. Alright, hopefully this wasn't too confusing. I know that I probably didn't do the best job teaching you this part right here, but if you have any questions, make sure and ask. We'll see you when we see you.